We've already identified both the objective function and the constraint function for example 1, and seen that really what we want to do with this constraint function is rewrite it so it's set equal to 0, which means in this case if we want to maximize this function, our goal is going to be to maximize f of xy equal to 2xy subject to x plus y minus 18 is equal to 0. Where again, the left-hand side of this equation, x plus y minus 18, is our expression g of xy. So to form our new function, capital F of x, y, lambda, we'll take our original objective function, 2xy, plus lambda times our constraint function, x plus y minus 18, and then distribute through. So this will become 2xy plus lambda x plus lambda y minus 18 lambda. So we have our function capital F. Now what we can do is find each of those three first derivatives. First with respect to x. So we'll take the derivative of this function term by term. So we'll get 2y plus lambda plus 0 plus 0. Which will give us 2y plus lambda. And then we'll set that result equal to 0. So this has two variables. We can't solve it on its own. We'll need to find one or both of the other derivatives, partial derivatives, so that we can solve this system. So we'll look at finding the partial derivative with respect to y, which will give us 2x plus 0 plus lambda minus 18, or no, I'm sorry, plus 0, so minus 18 lambda has no y variable. So we'll get 2x plus lambda, and also set that result equal to 0. And then we'll find the derivative with respect to lambda. So again, we treat lambda as a variable just like we would x or y. So the derivative of the first term would be 0, since there is no lambda variable, plus x plus y minus 18, or x plus y minus 18, and we set that equal to 0. So this gives us a system of three equations with three different variables to solve. So we could start with our first equation here and solve this for y. So we would get 2y equals negative lambda, or y equals negative lambda over 2. Similarly, we could solve the second equation for x. So we would get 2x equals negative lambda, or x equals negative lambda over 2. So now what we can do is take these substitutions that we have for both x and y, substitute them into our third equation here. So what we'll get for x is negative lambda over 2, plus, in place of y, we can again substitute in negative lambda over 2, minus 18 is equal to 0. So adding negative lambda over 2 and negative lambda over 2 will give us negative 2 lambda over 2 minus 18 equal to 0. So negative 2 over 2 will reduce to negative lambda minus 18 equals 0, which gives us negative lambda equals 18, or lambda equals negative 18. So what we've done so far is solved for this value lambda, which now we can substitute back into our expressions for y and x. So y is going to equal negative 18 over 2, or a positive 9. And similarly, x is going to be negative 18 over 2, or a positive 9. So we only found one point. So we only have one value for x, one value for y, one value for lambda, which means that that point is our maximum. And our maximum occurs at f of 9 comma 9, which is our x value comma y value. So to find our maximum function value, we would plug those into the original function. So our maximum function value would be 2 times 9 times 9, or 162. So our maximum occurs at the point 9 comma 9, and the maximum function value is a value of 162.